No, he said, I don't want to. Wait, did he think he said something in there? Matthew probably said, let's switch. Yeah, he did say that. Friggin' Gary.
Okay, so real quick, function transformations. There's some we didn't get through. I ran out of time yesterday. Something really important I need to show you. Yeah, there's more. Really important. Really important. This is, and it's important in a way that kind of even goes beyond just this book and this year. Some things I really want you to see. Okay, so how do we? What's the completely general template that we can write down for doing any kind of tweak that we want to do? First of all, how many different parameters are there that we can apply to a function to tweak it? Four. Okay. So what are they? A. What is it? Okay, so an A being the number. Let me just write it down. So if we're going to tweak. Okay, I got to restart this thing. Okay, so let's write this down now. So if I wanted to write down then g of x in terms of f of x, where do those numbers go? So a goes out front, f of, okay, 1 over b times, okay. Okay, good. So this is what, these are the
Okay,
four numbers that we can use to,
Okay. I was
right?
confused about the one would be, it's the horizontal one.
Right. Those are those four numbers that we can use to tweak the graph in any way we want to. I've got it more neatly written right there. Okay? Oops. Okay, so which one of those could we, by changing the sign, is going to reflect the function over the y-axis? Over the y-axis. B. Okay. Which one, if I change the sign, reflects it over the x-axis? A. Okay, good. So that does everything we need it to do. Now, we looked at a pretty complicated example yesterday, right? We looked at this example. And remember what we did with this. Let's kind of refresh our memories a little bit. This is right at the very end of the period. So we wanted to start with a simple parent function. That's always our strategy. Start with the easiest possible parent function, and then tweak it as necessary to produce some different function, right? So the parent function here was what? X squared. So we're just going to start with the simplest possible parabola, and then we have to do some stuff to it. So what were the things that we identified that we had to do? What's one thing we had to do here? What do you think? Tyler, get us started.
Reflect over the x-axis.
Okay, so one thing we had to do was reflect over the x-axis, okay? I'm going to hold off on that one. Any translations that we had to do? What were they?
Down 5.
So we had to go down 5 vertically, okay? And so that meant that k was -5, right? And what else? Horizontally to the right by how much? 27. So h was 27, right? Okay. We had to reflect it, and so reflecting it meant that a had to be negative, right? We had to do something else then. We decided that we wanted to take the two reference points that we normally would have for a parabola, and think about if we graph a parabola. If we graph a parabola, just the parent function parabola, f of x equals x squared, what are 3 points that goes through that allow us to kind of get oriented here? Obviously 0, 0, right? Goes through the origin. And what else? Okay, so if I plug in 1, I get 1. And if I plug in -1, I get 1. So those are my reference points, right? So I want to take those 3 reference points right there, and I want to tweak this thing, stretch it in such a way that it's going to accommodate those 3 points, right? So we've already flipped this thing, but imagine that it's not flipped yet. So let's just say that, let's say we haven't flipped this thing so it's upright. To get from there down to here, for example, how far, instead of moving over 1, how far did we actually move over? 15, right? So there's one stretch that we had to do. We had to take this function and we had to stretch this point out. So instead of being at 1, it was clear out here at 15, right? Everybody agree? So we're going to make this thing much wider. So which parameter is that affected by? What number do I have to dial in to do that? Okay, good. So we know, actually, was it 15? I think it was 25, not 15, right? Does that make sense? So to get from that point over to this point horizontally, or to this point, we're going by 25, not 15, right? Because we're going from an x value of 27 over back to an x value of 2, so 25 in that direction, or 27 plus 25 gives us 52, right? So let me fix that on here. So this should be, whoops, this should be, 25, and this is minus 25, right? Just really feel just the shape of the graph. Everybody with me? Okay? So that's one thing we did. But we also stretched it vertically, right? This point right here now, instead of being over 1 and down 1, we went down from -5 down to -20. So that's equivalent, how far is that? 15. Okay, so then we have to do one other thing to this point. We had to stretch it horizontally by a factor of 25, but our approach was then we're going to stretch it vertically by a factor of 15, right? Make sense? And so what number does that? A, okay? So does all this make sense now? If we account for all these numbers, there's our horizontal and vertical translations, there's our horizontal stretch, there's our vertical stretch and our reflection. Okay, make sense? So then what is our, if we want to write down the whole function then, what's our function going to look like if we compile all this stuff, given that our parent function was x squared? Let's write it 2 times. Let's write it once in terms of just plain old f of x, and then let's actually take our specific function and write out what the function would be. Okay, does that make sense? So what is g of x going to be then in terms of f of x? -15 times f of 1/25, 1 over b, right? 1/25. Times x minus 27. Whoops. Calgary. What? Minus 5. Okay? So now, what is our function though? Our function is x squared, right? So we did this yesterday. If f of x is x squared, what's f of 2? 2 squared. What's f of -3? Quantity -3 squared. What's f of a? What's f of a plus b? Plus b squared. What's f of 10? Whatever's behind my hand squared, right? Does that make sense? Okay, so then we get,
How do we know which order to do the reflections in?
the reflections,
Like what if there's a negative A value and a negative B value?
that's okay, then they're just both done. It's a good question. How do you know which order to do these in? And the answer is, it really doesn't matter. It really doesn't matter because you're doing each of these four things independent, right?
Oh, it doesn't matter.
I mean, you see what I'm saying? Does that make sense? Okay, so then we get what? Negative 15 times all of this stuff, right? This was hand right here, squared. Agreed? So I get all that stuff. And let's write it as one big fraction. If I multiply something by 1/25th, isn't that the same thing as just putting 25 on the bottom? Everybody agree? So then we get x minus 27 over 25 squared minus 5, right? Okay. And we can maybe do one more thing here. I think we've probably talked about this in Algebra 1. If I have something like the quantity a over b squared, what could I do with that? What could I do? A over b times a over b. Another way I could rewrite this is I could just write it as a squared over b squared. Does that make sense? So why don't we do that here? When I'm squaring, I've got a numerator squared and a denominator squared. So let's rewrite this just one more time. Let's rewrite this as negative 15 times the quantity x minus 27 squared. We're just going to leave it like that. That would be a mess to square out. So we'll just leave it as x minus 27 squared over 25 squared, which is 625, minus 5. So there's our final answer, okay? Did we have to do all that stuff? Well, I mean, we'll look at another way we can do this possibly. This is really cool. You got to really focus on this. Be able to see this. I really like this. Okay, so let's check and see if that worked. How about? Okay, show you a couple tricks here. If you want to get out your calculators, you can. In fact, it might be a good idea to go through this. If you need to grab one, go ahead. Here's some better ones up here. Okay, so a couple things I want to do. I want to show you a trick here. How many points define a line? 2. Okay, so if I did something, this is a really good trick. If I did something like, let's just say hypothetically, I want to find the equation of the line through the points. Let's say I want to find the equation of the line through the points 2, 17, and 5, negative 11. Okay. You could all do that, right? We could do that analytically, algebraically. We could find a slope. We could plug in the values of x and y to find b, and et cetera, et cetera. There's a shortcut here. There's a way in your calculator you can always do this really quickly. You told me that 2 points defines a line, correct? So if we go to our calculator, remember that regression stuff we did the other day? If I put in a whole bunch of points like we did the other day, I can find the best fit line really quickly by using regressional analysis. What do you think is going to happen if I put in exactly 2 points and do a linear regressional analysis. What do you think the best fit line through 2 points is going to look like? It's going to be a perfect fit, isn't it? Because 2 points defines a line, right? So watch what happens then. If I go into stat, edit, and let me clear this data out. So my x values were 2 and 5. And the corresponding y value, 17 and negative 11. Okay, watch what happens then if I do stat calc 4. And let's go ahead and store this as y1, how about? Notice what r squared is. What's r squared? What's that mean? 100% accurate. It's a perfect fit. Oh, yours not showing up? Go to mode, and then go down to stat diagnostics and turn it on. Stat diagnostics. It's way down on the next screen. Got to go way down. Hey, bring it up real quick. I'll do it.
Well, I don't have that information on there yet, but like when I was doing it last night, I kind of figured it out.
Oh, yours needs to be updated. I can still do it though. So you want to go on to TI and update. There it is. Oh, but that's for your old information. Yeah, but now it's on. Okay, so it's a perfect fit, right? If we go to the graph, if I just do zoom 9, there's our 2 data points, and what do you know? There's line goes right through them, right? It doesn't matter if yours looks exactly like that. I've got my scales a little different for reasons that you'll see why in a second. But you see the point there? So this is called a linear fit, right? This isn't a best fit line. This is an actual. I mean, we're actually finding out what the line through those 2 points is, and it is whatever we got back when we did our regressional analysis. That's the perfect line, right? Okay, so how many points do you suppose defines a parabola? 3. And we talked about this, I think, kind of at the beginning of the year, right? Just real briefly one day when we were discussing things. We said that if you take a line is the same thing as a first order polynomial, because the biggest power of x is 1. With a quadratic, the biggest power of x is 2. Cubic, the biggest power of x is 3. How many points does it take to define any of those, do you suppose? Whatever the biggest power of x is, whatever the exponent is, plus 1, right? So for a parabola, where the biggest power of x is x squared, it takes 3 points. For a cubic, it's going to take 4 points, etc. For now, we just need to know, though, that a parabola is defined by 3 points. So if we go back to our picture then, we have 3 points, don't we? Right there. So we should be able to perfectly fit this parabola to its equation by doing this trick, by using regression, right? Just like a line is defined by any 2 points, a parabola is defined by any 3. So if I put in those 3 points and do a quadratic regressional analysis, I'm also going to get r squared equals 1, and I'll get the exact shape. Agreed? So let's do that. So stat, edit, and let's see, in order, what do we got? 2, 27, 52 are our x values. And then negative, oops, can't do that. Negative 20, negative 5, negative 20. Okay, and so now what would I do? Stat, calc, 5. Okay, and let's go ahead and save this as y1. How do I get to the Y1?
How do you get to that?
Yours, you won't have that on yours till you update it. Okay, so there's the equation, right? Written in this form though, right? It's written in the form ax squared plus bx plus c. And notice that r squared equals 1. And if I go zoom 9, look what we see.
The R squared,
Uh-huh.
not on mine at all.
Not on yours. Okay, so real quick, if you're not seeing, let me talk you through this. If you're not seeing,
And that one.
everybody do this real quick on your calculators. Do this. On your calculator, go second memory, and then hit enter for about. So if you've got a TI-84 plus C or CE, you're going to be fine. You're going to be up to date enough. I think the newest operating system for the C calculators is the 5.2.0 point blah blah blah. You can always go to, if you just Google how to update your TI, you can just go to the TI site, and then I think you have to download some software called the. Have you guys done this?
No.
Okay, this is good to know. I'll take a little. Let me just show this to you.
Mine has that thing.
So what you'll do when you want to update your calculator, you'll go to TI and you download the software for your home computer called TI Connect, and then when you double click on that and you plug your calculator in, you can do things like send this one right here.
I don't have a calculator cord.
Okay, so you need to have that all you need is the USB cable that's got like the regular USB connection on one side and then the small one for your calculator on the other. Right? Does that make sense? Then you just go to this right here and you click on this thing and then you can just drag the new operating system which you download onto your calculator. Or I'll tell you what, when we're in the lab, I'll do it for you. Just bring it in and I'll do it for you. How's that? Okay.
Sounds good to me.
But you should know how to, that's not a bad thing to learn how to do.
What is with your screen? Why is
I don't know.
I don't really.
Is there like another teacher?
God, for real.
Okay, so back to business here. So then this is what we should see, right? Okay, so let's test our, now, so we get, this is the same exact parabola that's graphed here. If we want to tweak the window a little bit, we could tweak the window to make it look just like this one, but not necessary. You see that because our window's a little different, ours has been kind of maybe stretched a little bit vertically, but you get the idea, right? We can check ours. Ours looked like, there's ours, right? In fact, let's just leave it like this. We'll just leave it in this form right there. Okay? So I'm going to enter this. I'm going to enter this. This is our tweaked version of the parent function x squared that we did in order to try to match this parabola, right? Let's see if it works. If it overlaps perfectly with this one, then we did it correctly, right? Everybody agree?
How do you get
To what part?
where you can see the thing on the graph?
Mine doesn't work unless
You have to go to.
Dumb.
Okay, raise your hands. Listen, we got a lot of people here. I need you to raise your hands and ask questions. Okay, Jill, you had a question. So you want to know how to get the points on there, right?
Yeah.
Okay, to get the points on there, you have to have the plotter turned on. So you have to have plot 1 highlighted. Okay, and then Y1 right up there is that's the regression equation that the calculator built. Okay, that matches those points. Okay, now notice what I've got here already on there. It's not highlighted though, so it's not turned on yet, but that looks pretty familiar, doesn't it? Right? That is the function that we built, where A was negative 15, B was 25, H was 27, and K was negative 5, right? So let's turn this one on, right? This guy right here is just that put into my calculator, right?
So if we don't have the update, we have to do all that by ourselves.
No,
we just.
I know, but like.
No, you can't. I just don't want to take the time with everybody here to show you how to do it on the old system.
Okay.
It's not worth, I mean, because it's just too much time and it only affects a couple people. But, so you just remember how we did it with the new system, and then we'll get your calculator updated. Okay, so then if I go down and turn this one on by highlighting the equal sign, and I hit graph, did we get it right? We did, right? It matches that one perfectly. So that is the right answer, okay? However, on the assignment, if I put that in, I think it's not going to think that that's the right answer. I'm pretty sure. Let's look at the assignment real quick. If I go to, let's see here, hang on. Oh, I don't want to go through that hassle. But I know it's not. I know that it wants us to have this written in a way where there is no B. That seems weird, doesn't it? How could we do this without having a B? The B was the horizontal stretch, right? Okay, let me ask you something though. For this parabola, what's the difference between a horizontal stretch and a vertical stretch? Okay, true. But wouldn't you agree that if I took a, and this is the part that's you got to really focus on. I want you to get this. This is so cool that this works the way it does. It's one of those things in math where it's just amazing that it's all works the way it does. It's so self-consistent. So if I took, where's my graph of oh, right there. Okay. So we did this in 2 steps, right? We stretched it out, and then we stretched it horizontally by a factor of 25. Where is that thing? Remember what page that's on where I drew that? Right there, right? So we took the blue one and we stretched it horizontally by a factor of 25, and then we stretched it vertically by a factor of 15, right? Okay, but isn't a horizontal stretch, if I stretch something horizontally like this, isn't that really exactly equivalent to vertically compressing it? You see what I'm saying?
Yeah.
These parabolas go on forever, right? They're infinite in their scope. And so it's not, if I squash this thing down vertically, as I squash it down vertically, isn't that going to effectively make it wider horizontally? Do you agree? Right? I could also, if I wanted to, I could just do a single horizontal stretch that did exactly what I wanted it to do, instead of doing, really what I did here is I stretched it horizontally too far, and then I had to correct that by stretching it vertically a little bit, right? Because what I really wanted to do is I wanted this point to start, I wanted this point to start here and end up there. I did it in 2 steps. I stretched it horizontally to there and vertically to there, but couldn't I have just stretched it horizontally, for example, until this point lined up there, right? Here's what the parabola would look like, my final parabola. If I stretch it horizontally, if I had just stopped when my parabola went through this point, instead of going further out to here, I could have done it in 1 step, right? Just like I could have taken this thing and squashed it vertically until the parabola went through that point, right? You agree? How are we going to show that mathematically, though? Think about this now. If we look at the way our function is tweaked, the A and the B represent the horizontal and the vertical stretches. Well, let's not stretch it horizontally at all. So what's that make B? Not 0. 1, right? So let's let B equal 1 and not even worry about that. Is there a way then that we could, if that equals 1, that just goes away. Is there a way that we could fit it to just that function instead? Let's look at the algebra. Oops. Okay, we ended up here, right? we said, okay, well, we could use the fact that if I've got something divided by something squared, I could split that up. I could square the top and square the bottom, right? 25 squared was 625. Okay? We're one step away from being where we need to be. What could I do with this function, g of x, to make it look like a times f of x minus h plus k? Or in other words, a times x minus h squared, right? Because f of hand is just hand squared, plus k. Well, h is 27, right? K is -5. What would a be? What about this stuff? What can I do? What can I do with those numbers? What if I had something like, 9x over 12? When I multiply straight across, isn't that just 9x over 12? What can I do with the 9/12? You can simplify it, right? You reduce that fraction. That would be the same thing as what? 3/4x? Everybody agree? Isn't that just what I have here? Right? Okay, so what is 15 over 625? How many times does 15 go into 625? Somebody? No, 625 divided by 15 is what? Okay, so it doesn't go in evenly, does it? But 5 goes into both of those. 5 goes into 625, 125 times. So that'd be the same thing as I could reduce that to -3 1/25. Okay? So that would look like then I could take this function and I could write it as -3 125 times that. X minus 27 squared minus 5. Did I horizontally stretch that one or compress it? But I didn't, because there's no number that's being multiplied. See what I'm saying? There's no number that's being multiplied by inside these brackets. All I've got is a single number that's being multiplied by the whole thing. You get it? You see what I'm saying? That is so amazing you can do that. We didn't have to do two different things. All we had to do was one vertical compression, right? You see that? Because I got one number out front, right? So we reflected it and we compressed it quite a bit. It's only 3 125ths as big as it used to be. So it got squished way down. Okay, but we can show that that works. Look, let's graph it. Let's go on our calculator. And graph that one. So we'll graph that one down here. How about on y3? So now we've got the fraction, -3 125ths times the quantity x minus 27 squared minus 5. Everybody agree that's it? Okay, so watch what happens if I graph. How about that? Okay, it matches it perfectly, right? Okay, you with me? Okay, don't get sidetracked. Don't get sidetracked. You gotta really focus on it. So, is there a better way we could have done this? So, did we even have to? When we went back up here and we thought about this from the very beginning, did we even have to go through the extra? It worked. And this is fine. We can do it this way. But did we even have to go through the whole process of stretching it horizontally and vertically? Not really, right? Not really. All we really had to do was just say, okay, we know from the picture, how far this thing got translated. We know that it went over to the right by 27 and down by 5. And then the only other unknown in there, that represents h and k, right? If we're not going to stretch it horizontally, all we got to do is find out what a is, correct? Well, we could solve for a. We could solve for a because we know 3 points that our parabola goes through. And just like we do with a line, I want you to see this parallel. If we have, for example, a line that goes through the points 2, 3, and about 5, 11. Okay, and I want to match that to the form y equals mx plus b. Now I've only got 2 parameters here, right? Only got 2 parameters that I've got to plug in numbers for. What's the easiest one to find? Slope. Yeah, I can find slope. I've got 2 points, right? So I can easily calculate the slope between those points. What is the slope? What minus what? What is it again? 11 minus 3 over 5 minus 2. Well, I probably should have. Let's say that's a 4 instead, just to make the math a little bit easier for us. So that gives us what? 8 over 2, which is 4, right? Okay, so now what's my strategy? If I want to calculate what the other parameter is going to be, and I know places where the line, points through which the line travels. If I know points that the line travels through, those act as values of x and y that have to work, don't they? Isn't that what a point on a line is? Those are x and y values that match the equation, right? So if I want to find this guy, all I've got to do is take this equation, plug in the number that we know, the one parameter that we know, plug in a solution, meaning a value of x and y that has to work, and then how many unknowns would be left? 1. And if there's only one unknown in an equation, we can always solve for it, right? So we've done this a million times. I know this isn't anything new. This would just mean then that this number becomes, like, let's just pick this one because they're small numbers. 3 equals 4 times 2 plus b. So what's b? -5. If I turn that into an 8 and then subtract 8 from both sides, now I've got b, I've got m, I can fill in the blanks. You get it? Well, we can do that. That doesn't just work for lines. That works in any case, right? So if we've got this example over here where we know the 3 points that this parabola goes through, we know what h and k are, right? We know h, we already identified h is 27, k is -5, right? And we need one of the points that the parabola goes through, right? What was, do you remember what one of the points was? Pick the easiest one. 2, -20. We'll try that. And then all we're going to do is just match that to the form, we call it y, or we can call it f of x or g of x, it doesn't matter. Like we call it g of x equals a times x minus h squared plus k, right? Well, g of x is just like y. Same thing as y, right? So we know what h is, we know what k is, we have values of x and y that work, so what's the only unknown? A, you get it? We can do the same trick, right? So if we plug that stuff in, then we just get y is, what, -20? A, we don't know. That's the thing we're trying to find. But we got x minus 27. Oops. Squared plus -5. So what do I do to solve for A? Oops, I forgot to plug in x. What's x supposed to be? 2. What do I do? Simplify it, right? So what are the steps in order we would do to solve for A? We can simplify some stuff. What is 2 minus 27? -25 squared? 625. Okay, so this becomes -20 equals 625A minus 5. In order, what are the steps I do to solve for A? Add 5. So I get -15 equals 625A. So what's A equal?
-3/1.5.
Yeah. Right? And that simplifies to -325. You get that? Isn't that cool? Right? Okay. A lot of stuff. So that we can always do that with the parabola. You can just solve for A. Forget about B and just solve for A.